Hello class, Mr. Sutton here, and today we're going to be talking about solving systems of equations, this time with elimination. So last time we did substitution, and before that we did graphing, now we're going to do elimination. So the basic strategy, you want to make sure you put this in your notes, for using elimination is to combine the two equations in our system to eliminate one variable, creating an equation with one unknown quantity. So, for example, we have 5x plus 2y equals 10, 5x minus 2y equals 0. If I combine these two equations, I have a positive 5x plus positive 5x, so give me 10x. And then I have positive 2y plus a negative 2y, which would give me 0y, and then 10 plus 0 is 10. So notice we eliminated this variable here. Now we have 0 y's, so this is equivalent to 10x equals 10. Now we have one equation with one unknown, one variable here. So we can go ahead and solve this now. What was preventing us from solving this before is we had two unknowns. So now that we've eliminated one, we can go ahead and solve for x. So we can divide by 10 on both sides, and we get x equals 1. And then now that we know that x equals 1, we can use that to solve for y. So we can just plug this in to one of our other equations like we do for substitution. Now that we know that x equals 1, I'm going to go ahead and plug it into the first equation. So we have 5 times 1 plus 2y equals 10. So now, once again, I have an equation with one unknown. I can just solve this for y. So 5 times 1 is 5. Subtract 5 on both sides. So we get 2y equals 5. Then divide by both sides by 2. And you get y equals 5 halves. So the final answer would be 1 comma 5 halves. It's an ordered pair. Remember, it's a coordinates on a grid. So this is our final answer here. All right, so that's the basic strategy for these. So the first step for solving these equations using elimination is deciding what variable to eliminate. So some of these, it's set up in such a way that it's relatively obvious. So like for this one, for example, we have negative 3x and positive 3x. So those would be the easiest to eliminate. We don't have to do anything to eliminate those. We can just go ahead and combine these equations. So that's what we need in order to eliminate. We need the same coefficient, in this case 3, and opposite signs so that we can combine them and eliminate. So when I combine these, negative 3x plus 3x, we get 0, 3x. And then 10y plus 7y, you get 17y. 17 plus 17 would be 34. So the x term is eliminated. So then we just have 17y equals 34. And then we can divide both sides by 17. And we get y equals 2. And then from here, we can plug this back into one of these equations and solve for x. So I'm going to go ahead and do that now. All right, so here's the finished problem. I plugged 2 in for y for the first equation. So I got negative 3x plus 10 times 2 equals 17. So 10 times 2 is 20. Negative 3x plus 20 equals 17. Subtract 20 on both sides. So then you have negative 3x equals negative 3. 17 minus 20 is negative 3. Divide both sides by negative 3. So then you're left with x equals 1. Negative 3 divided by negative 3 is just 1. So x equals 1, y equals 2. You need to write that as an ordered pair. So that's 1 comma 2. All right, here's another example where first thing we need to do is try to decide what it is we want to eliminate. Now I'm looking at this and I think we want to eliminate x first. We have the same coefficient here. They're both 3, but this time they're the same sign. Now there's two ways to think about this. You could think about taking this equation and subtracting this equation. So then you'd have negative 3x minus a negative 3x, if I just look at this part here. And we know that minus a negative is the same as plus a positive. So we'd have negative 3x plus 3x equals 0x, right? So we would eliminate that x term. That's one way you could think about it. To think of subtracting all of this. The issue with that is a lot of times we forget that we're subtracting partway through the problem. So we'll get 0x here, and then we gotta go 10y minus 3y, so that would be 7y. And a lot of times we get to here and we'll say, oh, 2 plus 9 is 11, when that's not what we're doing, right? We need to subtract this, so it'd be 2 minus 9 is negative 7. So you could think about it as subtracting, or the other thing you could do is think about this as multiplying by a negative 1. So then what we'd have here is, if I go ahead and distribute all of this, we'd have positive 3x minus 3y minus 9. And then we can go ahead and combine our first equation, our second equation, like we normally would by adding. So we'd have negative 3x plus 3x is 0x. So we eliminated our x variable. 10y minus 3y is 7y. And then 2 minus negative 9 is negative 7. So we ended up in the same spot. 7y equals negative 7. So it's up to you, whatever it is that you're more comfortable with, whatever it is you feel you will make the less mistakes doing. I think generally this is the way people teach it, by multiplying by a negative 1 and then adding like normal. But if you feel more comfortable thinking about it as just subtraction, go for it. But make sure that you don't forget what you're doing halfway through the equation and then end up with the wrong answer. So go ahead and finish this one out. We want to divide by 7. So then you have y equals negative 7 divided by 7 is negative 1. Now we know what one of our variables is, so we can go ahead and plug that in to one of our original equations and solve for x. So I'm going to go ahead and do that now. Alright, so what I did with this negative 1 is I plugged it in for y in the first equation here. So we have negative 3x plus 10 times negative 1 equals 2. 10 times negative 1 is negative 10, so negative 3x minus 10 equals 2. Add 10 on both sides to get rid of the 10. So then you have negative 3x equals 12. To get rid of the negative 3, you got to divide both sides by negative 3. So then you're just left with the x equals 12 divided by negative 3 is negative 4. So x equals negative 4, y equals negative 1. Again, we want to write that as an ordered pair, negative 4, negative 1, in parentheses with a comma in between. All right. So on the last one, I had you multiply by negative 1 to set up the elimination. So there's going to be some where it's going to be a little more complicated to figure out what it is you want to eliminate. So we have this elimination guided practice on Delta Math that I want to check out here. So we can see as is, there's no variable we can eliminate. We have negative x, negative 6x, positive y, and negative 5y. So what we want to do is we want to multiply these equations by something in order to make it so something eliminates here. So there's two options you could do. There's more than two options, but there's two simple options I'm seeing right now. is you can multiply, if you want to eliminate the x, you can multiply the top by -6. So notice now it already distributes that for you. So now you have 6x minus 6y equals 24. So what I did was I changed the sign here. So now it's a positive and now it's a 6. So we have 6x minus 6x to give you 0x. And then -6y minus 5y would be -11 here. And then you'd add up those. So if you wanted to eliminate the x, that's what I would do. Or if you wanted to eliminate the y, this one I think is a little more straightforward because we have the -5y down here. So in order to eliminate the y, we need to make this positive 5y. So we would just multiply by 5. So then when you distribute, you have -5x plus 5y equals -20. So 5 times -4 is -20. So we can go ahead and combine these. So this bottom equation, I'm not going to multiply by anything. So I'm just going to put a 1 out in front here. I'm not sure if you can leave this blank or let's leave it blank, see what happens. So then -5x minus 6x, that would be -11x. 5y minus 5y is 0y, so that's what we want. And then -20 plus 42 would be a positive 22. So let's go ahead and try this. All right. So now we have our remaining equations, -11x equals 22. So we would have to divide both sides by -11, which would leave us with -2. So now we plug in x equals -2 into either equation and solve for y. So I'm going to go ahead and pause and do this now. So I plugged my -2 in here. So that would be -2, which is +2, plus y equals -4. So you'd subtract 2 on both sides. So you have y equals -4 minus 2 is -6. So if you plug it in here, make sure you're careful with your negatives. Same thing over here, actually. There's a lot of negatives either way you go. So final solution would be -2, -6. Let's go ahead and try this. All right, cool. All right, this one's interesting because so I'm looking at it, trying to decide what I want to eliminate. If I want to eliminate the x, we have x up here and -2x up here. So what I would want is I would want this to be a positive 2x. So I'd have to multiply the top equation by 2. Notice now we have 2x minus 2x gives us 0x. And then our y's. So pretty easy to eliminate the x. If you want to eliminate the y, there's nothing I can multiply this top equation by to make it match the bottom equation, unless I can multiply by a fraction here, can I? No, that doesn't work. So what you'd have to do is multiply both equations by something. So I would have to multiply this by 3 and this by 2. Now all of a sudden I have 6y minus 6y, right? Because 3 times 2y is 6y, 2 times -3y is -6y. So you can do that. And for some of these, you'll have to multiply both equations by if neither of the variables eliminate simply. But I think if you have the option to just multiply one equation, like we do in this one, that's the way to go. Because there's less room for error. Because for some of these, you're going to have to multiply this by yourself. And when you're distributing on 2 different equations, then you are creating more room for error. All right, so I went ahead and finished this one out. When you combine the equations, you get y equals 9. And then you plug 9 back into one of these equations, x plus 2 times 9 equals 8. 2 times 9 is 18. Subtract 18 on both sides, and you get x equals -10. All right, I want to talk about some special cases here. And these special cases are what happens when you eliminate one of your variables and actually both variables get eliminated at the same time. So if we look at this, if I eliminate the x here, the y is also going to be eliminated. If I combine these as is, what happens is you get 0x and 0y equals 0. So what is this? What does this mean? 0x plus 0y is just 0 equals 0. So what happens when both variables eliminate? You didn't do anything wrong. You just have to look at this final result and ask yourself, is this a true statement or a false statement? 0 equals 0 is true. So what that means is that this is an infinitely many solutions example here. What that means is these equations are actually the exact same. They're just written differently. If you divided this second equation by -1, you would see that these two equations are the same. So that means that the solution is every point on that line. These two lines intersect each other at every possible point, right? To take it back to the graphical example. So let's look at what happens in this other special case. So here, once again, both variables eliminate. We'd have 0x plus 0y. And this time, 3 minus 5 is -2, right? So in this case, 0x plus 0y is 0 was -2. So this is one where both of our variables eliminate, and we have to ask ourselves, is this a true statement or a false statement? 0 equals -2 is a false statement. So what that means is the answer is no solution. So these are our two answers for this. So this would be one where these two lines are exactly the same, so we have infinitely many solutions. And this would be one, if you graphed it, you would find that these two lines are exactly parallel to each other, so they do not intersect, meaning that there is no solution. All right. If you have any questions about any of these examples, make sure you ask for help at class or come to office hours. Have a good day, and I will see you in class. Bye.